All right, we're going to continue looking at Gaussian elimination by solving a linear system by achieving row echelon form using matrix row operations. All right, so when we're working with the matrix, these are some of the things we're allowed to do to the rows of the matrix. We can interchange rows. We can take one row and multiply each element in that row by a constant. Or we can add k times the elements in a particular row to a corresponding elements in another row. So these are the three things we're allowed to do with rows of a matrix. So here we have an example. We're going to use this matrix to perform each of the following row operations. Well, in example A here, just by looking at the notation, it almost says to me, it does say to me, switch or interchange row 1 and row 2. So what doesn't change is kind of how I approach this problem. Row 3 won't change. So I'm going to take row 3 and re-record it. And now I'm going to switch row 1 with row 2. And what I'm going to do is I'm going to indicate to the left over here what I just did. So halfway in between row 1 and row 2, I'm going to put the same notation, row 1 with that arrow, row 2. So if somebody looks at this, they might know, hey, we switched row 1 with row 2. Okay, example B. Using the given matrix right here, let's multiply, this is implied multiplication, let's multiply row 1 by 1/4. That's the same thing as saying take row 1, every element, and divide it by 4. Since multiplication by 1/4 is the same as dividing by 4. So when I go to perform that row operation, I think, okay, well, what didn't change? Well, row 2 and row 3 aren't going to change. So let me write down those two rows first. Okay, and then right here to the left of row 1, I'm going to put that notation 1/4 times row 1. It just reminds me that I need to take all of these elements and multiply by 1/4 or divide by 4. So 4 divided by 4 is 1. 12 divided by 4 is 3. Negative 20 divided by 4 is negative 5. And 8 divided by 4 is 2. So these are the allowed row operations, things that you can do. So let's look at this last one. And this last one right here, example C, is the one that's going to be a little more tricky. So it's important to kind of pay attention to this notation. You might think, okay, I'm going to multiply every element in row 2 by 3. And then after I do that, triple every element in row 2. I'm going to add that number to what's already present in row 3. So this is the row that's going to change, row 3. So whatever's last in this little expression, last being row 1, row 2, row 3 is last here, that's the row that's going to change. So what that tells me is row 1 and row 2 isn't going to change. So I'm going to come down here, and to the left of row 3, I'm going to re-record this little expression. So row 3 is going to be the changed row, so I'm going to go ahead and bring over row 1 and row 2. You might think, well, aren't you changing row 2? No, I'm just using the numbers in row 2 to multiply by 3 and then adding to what's currently in row 3. All right, so let's see how we're going to generate the elements in row 3. Well, I'm going to go back and look at the original matrix, keeping this in my mind, and go, okay, let me multiply 1, which is in row 2, by 3. So 3 times 1 is 3. And then I'm going to add it to what's already in row 3. So 1 times 3 is 3. 3 plus negative 3 is 0. So let's come back over here, go to row 2, multiply by 3, that's 18, plus -2, so the new entry is 16. Positive 3 times -3 is -9, plus 1 is -8. 3 times 7 plus -9, that would be 12. So these are the 3 allowed changes that you can make to rows. All right, I think it's time to go ahead and practice all that we've seen so far, okay, in solving a system of linear equations. So finally there, let's solve this linear system by using Gaussian elimination. So step 1 is to write the linear system as an augmented matrix. Step 2, we're going to use matrix row operations to simplify the matrix to row equivalent matrix in row echelon form. And then we're going to label each row operation, and then finally we'll be able to use back substitution to solve for the other variables. All right, step 1, let's come over here and write the augmented matrix. Watch out for your positive negative signs because it's easy to come from here to here and write down +1. That's going to throw everything off. So I would say it's important to attend to precision here. Always double checking to make sure that you re-recorded correctly. Okay, remember this is an augmented matrix, which means if I did put a vertical bar here, that's not necessary. That these are the coefficients of your terms and these are the constants. Okay, what we want to do is we want to change this augmented matrix to a matrix that's in row echelon form by using row operations, which means I want ones down the diagonal here with zeros, okay, below, so that I can jump off and solve. So, okay, our planning begins. We've got a lot of space here because it might take some time to put this in row echelon form. Well, I know that my top row should start with a 1, and currently my top row has a 2. So I'm actually just going to interchange row 1 and row 2 so that I do get a 1 that leads off row 1. So let's come over here, leave a little space so we can indicate what we're doing. I'm going to interchange row 1 and row 2. So halfway between row 1 and row 2, I'm going to put this notation. Row 1 switch with row 2. So my third row doesn't change. So write that down first, get that out of the way, and then let's interchange these rows. I'm gonna put a little arrow here to indicate my next move. Well, what I see is, okay, that I might actually take this second row and maybe move it to my third row, and I probably could have done that right from the beginning, taken top row and interchanged it with the third row. There's going to be a lot of different ways to enter into this problem, and so there's not just one way, so just kind of keep that in mind. You might have thought, well, hey, why didn't you just switch row 1 and row 3? And I could have, and I probably should have, but that's okay. I'll do that now. I'm actually going to switch now row 2 with row 3. So I'll put that in between here, row 2 and row 3. So my new row 1, working off this previous matrix, not the original one here, for this next move, will look like this. We'll tackle getting rid of this 2 and making that 1 a 0, okay? Now remember, row echelon form means that 1 should be made into a 0. How am I going to make that 1 into a 0? Well, if I divided by 1, I'm still not going to get a 0. So when you want to make a number a 0, we want to use that third row operation thing that we saw in the previous example. So what I'm going to do to make this a 0 is I'm actually going to think about taking row 1. Let's target these two numbers right here. If I made this a -1 and added it to a +1 and replaced it, that number here, that would be 0. Okay, I would get the 0 I need to start with. So let's multiply row 1 by negative, every element, and add it to what's in row 2. Don't worry about what's happening back here. Just worry about getting this 1 to be a 0. So I want to change row 2. So I'm going to put that last. So I'm going to take the opposite or negative of row 1 and add it to row 2. And remember, when you see this notation, this is the row that's going to change, the term that's last. Not this first term, but this last term. So what's not going to change? Row 1 and row 3. So let's record those rows because they won't change. All right, so now let's go back to the previous matrix and work off of it, performing these calculations. So opposite of 1 is -1, plus 1 is 0. Opposite of -1 is +1, plus 2 is 3. The opposite of 2 is -2, plus what's here, -3. Opposite of 9 plus 6 is -3. So step back and see what we have. Row 1 is good in row echelon form that I'm trying to achieve. Row 2 has a 0, that's good, but the first non-zero entry isn't 1. So how can I make that 3 a 1? Well, if I divided row 2 by 3, that would become a 1, which is what I want. So now I'm just going to work off of row 2, dividing every element by 3. So I'm going to come down here. I'm not changing row 1 or row 3, so let's re-record them. And then out here, it's 1/3 times row 2, or row 2 divided by 3. So what's 0 divided by 3? Well, it's still 0. So that didn't change the 0. You don't want to change that back to a number. You want to keep it 0. 3 divided by 3 is 1, and these two -3's divided by 3 would result in -1s. It's a slow process in getting your matrix to row echelon form, and you really have to attend to precision to make sure you're not making little computation mistakes. All right, now it's time to work on row 3. Row 1 and row 2 are good. Let's work on row 3. Okay, well, I need to get that 2 to be a 0 and that 1 to be a 0, but one step at a time. Let's work with this 2. If I divided 2 by 2, I'd get 1, but that's not going to help me. I want to make this 2 a 0. This is kind of what we did when we did elimination method. How would I get rid of this 2? Well, I could multiply this 1 by -2 and add that number then to 2, and that would result in a 0 here. So my plan is this: multiply row 1 by -2. So row 1 times -2, but then I have to add that, which will be -2, to row 3. So notice where I place this, this notation here, this expression, in front of row 3. So the only thing that's changing is row 3, so let's re-record row 1 and row 2. Okay, now working off the previous matrix, let's go and multiply 1 by -2, get -2, add it to 2, which is in row 3, and that's 0. All right, now multiply -1 by -2, that's +2, plus 1, that's 3. This will be an issue, I'll take care of it later. -2 times 2 is -4, plus 2 is -2. -2 times 9 is -18, plus 18 is 0. Is this matrix in row echelon form? No, I need a 0 here and a 1 here. So the next thing for me to work on is changing this 3 to a 0. All right, I am not going to work with row 1 to change this 3 to a 0. I'm going to work with row 2 because this 0's here, and if I added something that I multiply 0 by to another 0, I'm still going to get a 0. I need that 0 to stay the same. That's going to be up front. So I'm going to come to row 2, and to get rid of 3, if I multiplied 1 by -3 and added it to 3, I'd get 0. So I'm going to multiply row 2 by -3 and add it to row 3. So row 1 and row 2 stay the same. They're good to go. So let's come back to row 2. That's what this little expression tells me. Negative 3 times 0 is still 0. 0 plus 0 keeps my 0. Negative 3 times 1 plus 3 is 0. Negative 3 times negative 1 is positive 3. Positive 3 plus negative 2 is a 1. We got lucky. We got that 0 here, but we also got a 1, which is necessary. All right, and for this last entry, negative 3 here gives us positive 3 plus 0 is 3. Had this not turned into a 1, my last move would be to take this number and divide it by itself to get a 1 here. But we actually got lucky there. Okay, so now this matrix in reduced or in row echelon form represents a system of equations. So let's start from the bottom row. Remember, this is the x term, y term, z term. So if I wanted to change this back to a system of equations, then I know that I would have 1x minus y plus 2z equals 9. For the second row, I'd have 0 x's. I'm not even going to write it down. 1y minus z equals negative 1. And for the last row, no x's, no y's, this is z equals 3. So far we know what z is, and now what we have to do is back substitute to get y, and then once we get y from this equation, we can get x. So let's find y. So recording y minus z equals negative 1, and where I see z, I'll replace it with 3. So y is equal to 2. Now we can find x because we have the other two variables. So I'm going to go to the first equation here and insert my y and z values. Let's do the multiplication first. Maybe clean this up over here. And then subtract the 4. So my final solution in the ordered triple form, x, y, z, is 5, 2, 3. Now, you might think, well, once you have y and z, and if you want to find x, could you go back to the original equation? Yeah, it doesn't matter. It doesn't matter what equation you choose. Okay, I just wanted to choose this equation right here for my augmented matrix. All right, this last example we're not going to look at and do because we would have to take this matrix right here and change it to reduced row echelon. And this is already enough. Changing to row echelon, reduced row is just a little more challenging. So this is not necessary. Let's do one more example of solving a system using Gaussian elimination. You guys don't have this example, so if you want to stop and get a piece of paper, I think it would be a good idea to do one more of this method. Certainly, if you feel comfortable, fine. But if you need another example, I wanted to provide one more at least for you. Okay. All right, let's solve this system using Gaussian elimination. So let's write the augmented matrix, put the matrix in row echelon form, and then do some back substituting. Okay. All right. Row 1 looks good. It starts with the 1, so I'll just leave row 1 as it is. I'm going to work on row 2 next. I need this negative 1 to be a 0. If I added row 1 to row 2, okay, these two numbers would result in a 0, so that's what I'm going to do. I'm changing row 2. So row 1 plus row 2. Row 2 is the last term, so that means that's the row that's going to change. It tells me to add row 1 and row 2, replacing row 2 with that new number. So that sum is 0. That sum is 1. Add 3 and 1, that's 4. Add 9 and negative 2, and that's 7. And look what just happened. By your getting a 0 here, we got lucky, we got a 1 here. Had I not gotten a 1 here, say that was 5, I would go through and divide every element in this row by 5. And that would result in getting a 1 here so that I could move to row 3 and make changes. Okay, time to work on row 3. Okay, I'm going to change the numbers, elements in row 3. And the first thing you want to do is get rid of 2. Well, I'm going to multiply row 1 by negative 2 and add it to 2, and that would result in a 0. So I'm changing row 3 by multiplying row 1 by negative 2. So using the previous matrix, not the original one, go from your last entry here. Negative 2 times 1, negative 2 plus 2 is 0. Negative 2 times negative 2 is positive 4, plus negative 5 is negative 1. Negative 2 times 3 is negative 6, plus 5 is negative 1. Negative 18, when I multiply, that's also negative 1. Okay, remember we're looking for row echelon form, so we need 1s down the diagonal. That negative 1 needs to go to a 0. So to make this a 0, I'm not going to go to row 1 because I have a 1 here and I don't need to change this 0. So if you just added row 2 to row 3, that would accomplish getting a 0 here. So that's what we're going to do next. We're going to take row 2 and add it to row 3. So row 1 and row 2 aren't changing. The only thing changing is row 3. Okay, go back to the previous matrix. 0 plus 0 keeps your 0. 1 plus negative 1 is 0. The sum here is 3, and this sum is 6. Not quite in row echelon form, almost though. To be in row echelon form, I need that 3 right here to be a 1. The way to get this to be a 1, not a 0, is divide 3 by 3 and get a 1. So I'm just going to divide row 3 by a 3 to accomplish getting a 1 here. So 1/3 times row 3. So 0 divided by 3 is still 0. Again, 0. 3 divided by 3 is 1. 6 divided by 3 is 2. Kind of a built-in check process here is if you're getting really ugly numbers, chances are you made a mistake earlier, and that's kind of sad because to find that might be difficult. Okay, my matrix is now in row echelon form. I'm ready to jump off of this. I'm going to go ahead and write this back as a system. No x's, 1y, plus 4z equals 7. No x, no y, 1z, I'll put it here, equals 2. So now that I know what z is, I'd go to the previous line, and because I know z, I'll find y. Now that we have y and z, now we can go back, now that we have y and z, and find x. So I'm going to pull down that top equation. So this multiplication results in plus 2 plus 6 equals 9. Adding together and subtracting 8. So we solved this system using Gaussian elimination. We got 1, -1, and 2.